everyone. So now we are going to deal with the chemistry questions from NEET paper 2022. So question number 51 is from the chapter thermodynamics, and the question is, which of the following PV curve represents maximum work done? Okay. So PV curve means pressure versus volume curve. Now we know that in any thermodynamic process, the work done can be calculated as the area under the PV curve. That means area under the pressure versus volume curve, right? So out of the given options, which has maximum area? You can see that in option 3 there is just a line, so there is no area in this, so this cannot be the correct answer. Okay, in option 1 here the area is very small. Okay, so this is also not correct, and out of 2 and 4 it is quite clear that 2 has the greater area, so the work done will be maximum in second option. Okay. Now question number 52 is from the chapter P block elements, and the question is, given below are two statements. One is labeled as assertion and the other is labeled as reason. So assertion is that ICl is more reactive than iodine. That means iodine chloride is more reactive than iodine molecule. And the reason is given as iodine chloride bond is weaker than iodine bond. Okay. So both are correct and reason is the correct explanation of assertion. So A will be the correct answer. Okay. So just remember that if we talk about the bond strength, okay. So the bond strength of interhalogen compound is less than the pure halogen. Okay. Therefore, this bond will break easily because it is weaker. So when it will break easily, it will react fast, right? So we can say that the reactivity of the interhalogen compound will be more than the halogen molecule. Okay. Therefore, reason is the correct explanation of assertion. Now question number 53 is from the chapter hydrocarbons, and the question is, which compound amongst the following is not an aromatic compound? Okay. So which rule do we follow to determine an aromatic compound? We use Huckel rule. According to this rule, there are two conditions for a compound to be aromatic. First, the electrons should be in conjugation. That means electrons should move in the complete ring. Okay. And the second condition is that 4n plus 2 rule should be followed. That means the total number of pi electrons should be 4n plus 2, where n is any non-negative integer. Okay. So now let's talk about the first rule, first condition, that means electrons should be in conjugation. So let's see in the given options if the electrons are in conjugation. So in the first one you can see this is an electron. Okay. So this electron will move towards this, then this electron will move here, right? Again this will move from here. So there is electron conjugation in this case. So it is an aromatic compound, right? Now if we talk about the second option, here you can see there is a positive charge, so definitely pi electron will be attracted towards this. Okay, then here positive charge will be developed. Again this electron will be attracted towards this positive charge, so this will go on. Again this is also an aromatic compound. Okay, according to the first condition. In the third one you can see again there is a positive charge, so pi electron will be attracted here. Okay, again this is aromatic. Now in the last one we can see that there is no condition under which the electrons should move. Okay, so according to this, this should not be an aromatic compound. Okay, so on the basis of the first condition only we could find out that option D is not an aromatic compound. Okay. Question number 54 is from the chapter Organic Chemistry, and the question is, the IUPAC name of an element with atomic number 119 is. Okay. So here we know that whenever we have to write the IUPAC name of an element on the basis of atomic number, then what do we write? For 0 we write nil, for 1 we write un, for 2 we write bi, for 3 we write tri, for 4 we write quad, for 5 we write pent, for 6 it is hex. For 7 it is sept. For 8 we write oct. For 9 we write n, right? And at last we add IUM, that means EM. So let's name this 119. For 1 we write what? Un. Okay. So for this we write un. Again one more 1 is there, that means one more un should be there. And at last we have 9, that means n should be there. Okay. And at last what we add? IUM. So the correct answer should be unnium. That means the A should be the correct answer, right? Now let's discuss the other options as well. In the second one we have nil That means that means 1, nil means 0, n means 9, and we write em at last. Okay, so it is 109. For the third one we have unium. That means 111, right? For the last one we have unoctium. That means 118. Okay, so for the given atomic number, that is 119, the correct option is option number A. Question number 55 is from the chapter Chemistry in Everyday Life, and here we have to match the drug class with the correct drug molecule. Okay, so the first one is antacid. So here, as the name suggests, it is used against the acidity. Okay, and the correct match for this is cimetidine. Okay, cimetidine, and it is used against acidity. Right? Now the next one is antihistamines. So what is the example of antihistamine drugs? It is Seldane. Okay. And what is it used for? It is used against the allergy or inflammation. Okay. The third one is analgesics. So these class of drugs include morphine. And what is the use? These are used as painkillers. Okay, these are used to relieve the pain. And the last one is antimicrobials. That means they are used to fight the microbial infections. Okay, and the example for this is salvarsan. So out of the given options, which should be the correct one? Option B should be the correct one. Question number 56 is from the chapter hydrogens, and here we have to match the hydrides with their nature. So in order to solve this question, first we should know about the octet rule. What do you mean by octet rule? According to this rule, in any covalent bond, what is covalent bond? The bond that is formed after sharing of electrons between the atoms, right? So in any such bond, each atom should have 8 number of valence electrons, right? Should have 8 valence electrons. Now, the atoms which have less than 8 valence electrons, those will be known as electron deficient, while those having more than 8 valence electrons will be electron rich in nature, and the atoms having exactly 8 valence electrons will be electron precise. Okay. Now, another thing that you should remember, that hydrides are of two types. Okay. First one is the ionic or saline hydride. Second one is the covalent or molecular hydride, right? Again, covalent are of three types: electron deficient, electron precise, that we have just now discussed, right? And the electron rich covalent. Okay. So now we have to find out which compound belong to which of the groups. So for that, remember that all the elements of group 1 and 2 make the ionic hydride. Okay, ionic or saline hydride. All the elements of group 13 form electron deficient hydride. Group 14 elements form electron precise hydrides, and 15 onwards will form electron rich hydrides. Okay, so now the first one, that means magnesium hydride, so it is group 2 element, right? That means it will form the ionic hydride, so the correct match for A will be 4, right? Now the next one is germanium hydride. So germanium is group 14 element, so group 14 will form electron precise, so the correct match for B will be number 1, right? Third one is boron. So boron belong to group 13 element, and group 13 element will form electron deficient hydride. That means the correct match for C will be number 2. And the last one is hydrogen fluoride. So this is fluorine, which belongs to group 16. So we have seen that 15 onward it will be electron rich, so it will belong to the electron rich hydride. So the correct option for D will be number 3. So out of the given options, which should be correct? A4, that means the first one here. Okay, option A is the correct answer. Now question number 57 is from the chapter Chemistry in Everyday Life, and here we have to find the incorrect statement regarding the enzymes. Okay, so the first statement is enzymes are biocatalysts. So what do you mean by catalysts? These are the substances which enhance the rate of reactions. Okay, so enzymes are biocatalysts because they enhance the rate of biochemical reactions. That means the reactions going on inside our body, right? Now, so this is the correct statement. Now we come to the second one. Like chemical catalysts, enzymes reduce the activation energy of bioprocesses. Again, this is a correct statement. So suppose this is the graph showing the reaction. So here we have the reactant, and this is the activation energy without catalyst or without the enzyme. So this is the energy without enzyme. So what will happen when we'll use the enzyme? The activation energy will be reduced. So it will be the energy with enzymes. Okay. So due to this, the reaction will proceed faster. So this is also a correct statement. Now the third one is enzymes are polysaccharides. So this is not true. Why? Because the enzymes are protein in nature, not the polysaccharides, right? And option D is enzymes are very specific for a particular reaction and substrate. So this is also correct because these are very specific. Now, so according to the question, the incorrect statement is statement C. Question number 58 is from the chapter coordination compound, and here we have to find the IUPAC name of the given complex. Okay, so here first we have silver, then water molecule is the ligand here. Okay, then in the second part we have again silver, then two cyano group. Okay, so when we name it, we use the ligand first. So for the first part, water molecule is the ligand. Okay, and how many water molecules? Two molecules. So for two we write di, for water we write aqua. Okay, and this is silver, so di aqua silver, and the oxidation state of silver is 1, so here we'll write 1. And for the next part, there are two cyano groups, so we'll write dicyanide, again silver, but this time we will use the term arginate. Okay, so we'll write arginate. Again the oxidation state is 1, so it will be 1. Okay, so out of the given options, option D will be the correct answer. Now question number 59 is from the D and F block elements, and the question is gadolinium has a low value of third ionization enthalpy because of small size, high exchange enthalpy, high electronegativity, or high basic character. So the correct option is option B, that is high exchange enthalpy. Okay, let's see how. First we'll write the electronic configuration of gadolinium. It is xenon plus 4f7 5d1 6s2, right? Now in the first two ionizations, these 2 electrons will be removed, and in the third ionization 5d1 will also be removed. So let's write it down. After third ionization, 5d electron will be removed, right? So what will be left after that? 4f7 will be left. Now this is special because we know that F sub shell has how many electrons? 14 electrons, right? 7 orbitals or 14 electrons. So here we have 7 electrons. So we can say that this is half filled, and we know that half filled and completely filled orbitals are very stable. Therefore, it will be very stable, right? So the third ionization is leading to a very stable state, right? Therefore, this half filled, that means 4f7, will be very stable, and due to this it will have very high exchange energy, right? And this is the reason why very low energy will be required for the third ionization. Therefore, option B is the correct answer. Question number 60 is from the chapter Chemical Bonding and Molecular Structure. And the question is, amongst the following, which one will have maximum lone pair electron repulsions? Okay. So to understand this, we should draw the structure first. So first one is ClF3. Now chlorine belongs to group 17 elements. That means it will have 7 electrons in the outermost shell. So out of these 7, we have 3 electrons which are shared with the fluorine atoms, right? So how many left? 7 minus 3, that means 4. So we can say that 2 pairs of electrons are left, right? Now the next one is IF5. Iodine also belongs to group 17. So it also has 7 electrons. And out of these 7, there are 5 electrons which are shared with the fluorine atoms. So how many left? Only 2 left. So we can say that only 1 pair of electrons is left. Now in the third one, that is SF4, we know that sulfur belongs to group 16 elements. So it has 6 electrons in the outermost shell. So out of these 6, 4 electrons are shared with the fluorine atoms, right? So how many left? Only 2 electrons left. So we can say 1 pair of electrons left, okay? And the last one is xenon difluoride. Okay, so xenon belongs to group 18, so it has 8 numbers of valence electrons. Out of 8, 2 are shared with the fluorine, right? So 1 here, 1 here. So how many electrons left? 6 electrons left, or 3 pairs of electrons left. Okay, so we can see clearly that the maximum number of electron pairs or lone pairs of electrons are present in xenon. Therefore, there will be the maximum lone pair repulsion in xenon difluoride. Okay, so option D will be the correct answer. Question number 61 is from the P block elements, and the question is, which of the following statement is not correct about diborane? Option A, there are two 3-centered 2-electron bonds. Option B, the 4 terminal boron hydrogen bonds are 2-centered 2-electron bonds. Option C, the 4 terminal hydrogen atoms and the 2 boron atoms lie in one plane. And the last option is both the boron atoms are sp2 hybridized. Okay, so let's have a look at the structure of diborane. So we have 2 boron atoms and each one of them are attached to 2 terminal hydrogen atoms, right? That means total we have 4 terminal hydrogens and 2 boron which lie in the same plane. So option C is a correct statement. That means the 4 terminal hydrogens and 2 boron atoms lie in one plane, right? Now, in addition to these terminal hydrogens, boron atoms are also attached to a common hydrogen. Okay, here. So this is something like that. Boron attached to themselves and then boron attached to hydrogen as well. Okay. Similarly, this side as well, it looks like this. Okay. So if I draw this figure again, the middle one, then boron, hydrogen and boron. I'm not mentioning the terminal hydrogens here. So you can see there are 3 atoms. That means there are 3 centers, but only 2 electrons that are shared between them. Okay, so this is an electron deficient bond, right? And this bond is known as 3 center 2 electron bond. Got it? So we can see that there are 2 such 3 center 2 electron bonds. First on the upper part and second on the lower part, right? So first statement is also correct that there are 2 3 center 2 electron bonds, right? That means 2 electrons are shared by the 3 atoms. But here on the terminal part, if we see, there are this bond, that means suppose boron and hydrogen. So 2 atoms are there and 2 electrons are shared, one by hydrogen and one by boron. Okay, so this is 2 center 2 electron bonds. So we can say that the 4 terminal, this second statement, 4 terminal boron hydrogen bonds are 2 center 2 electron bonds. So this is also correct statement. So only incorrect statement is statement D, because both the boron atoms are sp3 hybridized, not sp2 hybridized. Okay. Question number 62 is from the chapter Aldehydes, Ketones and Carboxylic Acids. Here we are given 2 statements. First statement is the boiling points of aldehydes and ketones are higher than hydrocarbons of comparable molecular masses because of weak molecular association in aldehydes and ketones due to dipole-dipole interactions. Okay, so let's analyze this statement first. We know that aldehydes and ketones consist of carbonyl groups, right? That means C double bond O. Now oxygen is more electronegative than carbon, so the electron will be attracted to oxygen and oxygen will acquire a partially negative charge, whereas carbon will acquire a partially positive charge, right? And same will be the case with all the carbonyl groups. Now the partially negative oxygen will bind with the partially positive carbon of another carbonyl group, right? So you can see that there is development of polarity. That means there will be dipole-dipole interaction in case of aldehydes and ketones, which will lead to the intermolecular association. Okay. Due to this reason, the boiling point of aldehydes and ketones will be higher than hydrocarbons of comparable molecular masses, because hydrocarbons are non-polar in nature. Okay. Non-polar. Now we come to the second statement. We know that first statement is correct, right? So now we move to the second one. The boiling points of aldehydes and ketones are lower than alcohols of similar molecular masses due to the absence of hydrogen bonding. Okay. So now we saw that it is more than the hydrocarbons. And in the next statement, it is saying that it is lower than the alcohols. So let's see how and why. If I draw the structure of alcohol, we know it is some alkyl group and then oxygen and then a hydrogen, right? OH group is there. For another alcohol molecule, it will be again alkyl molecule, then oxygen and then hydrogen. Now you can see that again oxygen is more electronegative than hydrogen. So it will acquire a partially negative charge, whereas hydrogen will acquire a partially positive charge. Okay. Here as well. Now the more electronegative oxygen will bind with the hydrogen, that means partially positive hydrogen of another alcohol molecule, right? So here there will be hydrogen bonding. So in the previous case, that means in the aldehydes and ketones, there was dipole-dipole interaction, whereas here there is hydrogen bonding, and we know that hydrogen bonding is typically stronger than the dipole-dipole interaction. Got it? Due to this, it is more difficult to break the hydrogen bonding in comparison to the dipole-dipole interaction, because dipole-dipole is comparatively weaker as compared to the hydrogen bonding, right? So the boiling point will be of alcohol will be higher than the aldehydes. So second statement is also correct. So out of the given options, option A will be correct. Both statement 1 and 2 are correct. Question number 63 is from the solid states. Here we are given two statements. One is assertion and the other is reason. Assertion is that in a particular point defect, an ionic solid is electrically neutral even if few of its cations are missing from its unit cells. And the reason is in an ionic solid, Frenkel defect arises due to dislocation of cation from its lattice site to the interstitial site, maintaining overall electrical neutrality. Okay. Now to understand this, first we should remember that there are mainly two types of point defects. First one is stoichiometric. In this, the overall stoichiometry is maintained, whereas in the non-stoichiometric defects, the stoichiometry of the solid is disturbed. Okay. Now, in the stoichiometric, there are two main types of defects. First one is the Schottky defect and the other one is the Frenkel defect. Now, this question is related to the types of stoichiometric defects. Okay, in the first statement it is given that the electrically neutral solid is there, but the cations are missing from the unit cells. Okay, so this is the statement about Schottky defect, whereas in the reason Frenkel defect is mentioned. Okay, what is the main reason? Suppose this is the solid. These are the cations, the round ones, and square ones are the anions. Okay. So suppose if one cation is missing from here, then one anion will also be missing from here. Okay. So if one positive charge is removed, then an equal negative charge will also be removed. So the electrical neutrality will be maintained in the solid, right? Whereas in Frenkel defect, what happens? The cations just move from their lattice site to the interstitial site. Okay, they do not leave the unit cell. Okay, so both the statements are correct, but these are talking about different types of defects. These are not related to each other. So option B will be the correct answer. That reason is not the correct explanation of assertion. Okay. Question number 64 is from the P block elements. Here we are given two statements again. First statement is the boiling points of the following hydrides of group 16 elements increases in the order. So this is the order, as we can see, from oxygen to tellurium, that means down the group, the boiling point of hydrides is increasing. And in statement 2, it is mentioned that the boiling points of these hydrides increase with increase in molar mass. Okay, so both these statements are partially correct but partially incorrect as well. Why? Let's see. From hydrogen sulfide to hydrogen telluride, this will be the sequence as mentioned in the question. But here it is given that water is having minimum boiling point, which is not true because water is the exceptional case here and it has the maximum boiling point. Okay, so the first statement is incorrect. Now let's see the reason why water has the maximum boiling point. The reason is extensive hydrogen bonding in water molecule. So I'm drawing two water molecules here. One is this, second is this. We know that oxygen is more electronegative, so it will acquire a partially negative charge, whereas hydrogen will acquire a partially positive charge. Okay, similarly here as well. Now the partially negative oxygen will bind with the partially positive hydrogen. So this is the hydrogen bond, and this type of hydrogen bonding will exist throughout water molecules. Due to this, water molecule will have very high boiling point. Okay, so this is the correct sequence here, and the reason is also incorrect because other than molar mass, the hydrogen bond is also the reason for the correct sequence here. Okay, so out of the given option, option B will be correct. Both statement 1 and 2 are incorrect. Okay, I am also mentioning the boiling points of each one of them. Water has the boiling point of 373 Kelvin. Then hydrogen telluride 269 Kelvin. Then hydrogen selenide 232 Kelvin, and hydrogen sulfide has 213 Kelvin. Okay. Question number 65 is from the chapter Chemical Kinetics, and the question is, the given graph is a representation of kinetics of a reaction. The y and x axis for 0 and first order reactions respectively are. Okay, so we have to determine y and x for 0 as well as for first order reaction. Now we can see that y is constant throughout x. Okay, so we have to find out which quantity remains constant in case of 0 order and in case of first order reaction. So let's talk about the 0 order reaction first. We know that in 0 order reaction the rate of the reaction R is equal to K into A to the power 0. Now A to the power 0 means what? 1. So rate will be equal to K, that is a constant. Okay, so y should be the rate in case of 0 order reaction. So either option C or option D should be correct, and x will be the concentration because concentration is changing but rate is not changing. Now we'll talk about the first order reaction. Okay, so we know that in case of first order reaction, half-life is given as 0.693 divided by K. Again, this whole quantity is a constant. So what will remain constant in case of first order reaction? Half-life. Okay. So in option D it is given rate. So it is not correct. This is the correct. Half-life is constant in case of first order reaction, and x will be the concentration here as well. So option C will be the correct answer. Question number 66 is from the chapter Haloalkanes and Haloarenes, and here we have some statements about chirality and we have to find out the incorrect statement. Okay, so we'll discuss the statements one by one, but before that let's understand what is chirality. Suppose we have a mirror here and on the right side of the mirror an object is kept, say a cup is kept. Okay, so on the left side its mirror image will be there. So it will look something like this. That means the image will be inverted, isn't it? So if we put this cup on its mirror image, will these two be superimposable? No, because the part on the right side of the object is on the left side in case of image, right? So these will be non-superimposable, and such objects are known as chiral objects, and this property is known as chirality. Got it? Now let's familiarize ourselves with another term here, that is enantiomers, that is mentioned in option C. So enantiomers are the stereoisomers which are related to each other as non-superimposable mirror images. Got it? So these are non-superimposable stereoisomers. And what is mentioned in the option? Here it is given that the enantiomers are superimposable mirror images, which is not true. So this is an incorrect statement. Okay, so we have already got the incorrect statement here, that is option C. But let's discuss other options as well. First one is SN1 reaction yields 1:1 mixture of both enantiomers. So what do we mean by 1:1 mixture of both enantiomers? Let's understand this. Suppose we have a compound. This is the central atom, that is carbon, and there are 4 groups attached to it. One is methyl group, second is hydrogen, third is ethyl group, and the fourth one is an unknown group X. Okay, now a reaction has to take place such that this X has to be replaced by another group Y. Okay, so how will it happen? The reaction can take place in 3 different ways. In the first one, a compound A will be obtained such that the overall structure will remain same. That means the position of each group will remain same. There will be just one difference, that X will be replaced by Y. Okay, and the position will be same here. So this is known as retention. Got it? Now, the second possibility is that the compound will be inverted. That means the groups on the right side here will be on the left side in this way. Okay, CH3, C, then here H, and then here ethyl group C2H5, and Y will be here. Okay, so you can see here this is inverted. That means this is compound B and this is known as inversion. So these are two possibilities. In addition to these, there is a third possibility that a mixture of both A and B can be obtained, and this is known as racemization. Got it? And this, in this racemization, there will be zero optical rotation. Now, let's discuss the options. First one is SN1 reaction yields 1:1 mixture of both enantiomers. That means racemization will take place, right? So this is a correct statement because in case of SN1 reaction, racemization takes place. So SN1 here. Whereas in case of SN2, what happens? Inversion takes place. Okay. So statement 1 is correct. Then statement 2, it is given that the product obtained by SN2 reaction of haloalkane having chirality at the reactive site shows inversion of configuration. So this is also a correct statement. Okay, and in the last option it is given a racemic mixture shows zero optical rotation. So this is also true. Why? Because rotation due to one will be cancelled due to the rotation by another. Okay, so the only incorrect statement here is option C. Got it? Question number 67 is again from the chapter haloalkanes and haloarenes, and the question is which of the following sequence of reactions is suitable to synthesize chlorobenzene? Okay, so out of the given options, option A will be the correct answer because simple halogenation of benzene will take place to form chlorobenzene. Okay, so the required halogen here is chlorine. So benzene will react with chlorine in the presence of anhydrous FeCl3 to give chlorobenzene. Okay. Now, why do we use ferrous chloride? Because we know that generally benzene is not so reactive and halogen is not electrophilic enough to break the aromaticity of benzene. So this FeCl3 acts as the electrophile and due to this halogenation takes place easily. Okay, so option A is the correct answer. Question number 68 is from the chapter Structure of Atom, and the question is identify the incorrect statement from the following. First statement is all the five 5d orbitals are different in size when compared to the respective 4d orbitals. Okay, so here we have to compare the size of 5d and 4d orbitals. So for that we should know what does size of the orbital depend on. So it depends on the principal quantum number. Okay, principal quantum number is denoted by letter n. So for 5d orbital, the principal quantum number is 5, whereas for 4d orbitals, the principal quantum number is 4. So we can see that the principal quantum numbers are different for both, therefore size will also be different. Okay, so different size of orbitals. This means that the first statement is correct one. Okay. Now the next statement is all the five 4d orbitals have shapes similar to the respective 3d orbitals. So here we have to compare the shapes of 4d and 3d orbitals. So what does shape of the orbital depend on? It depends on the azimuthal quantum number. Okay. Azimuthal quantum number is denoted by letter L. So here we should remember that for s orbital, the principal this azimuthal quantum number is 0. For p orbital, azimuthal quantum number is 1. For d orbital, L is equal to 2, and for f orbital, L is equal to 3. Okay, so here we have to compare the shapes of 4d and 3d orbitals, right? So for 4d, the azimuthal quantum number is what? 2, because for d orbital it is always 2. Similarly, for 3d orbital also it is 2. So this means that the azimuthal quantum number is same for both. That means they will have same shape of orbitals, right? Or similar shapes of orbitals. Let's write similar here. Okay. So option B is also a correct statement, right? Now, the third one is in an atom, all the 5 3D orbitals are equal in energy in free state. Again, this is a correct statement because these are in equal energy level. Okay. And the last one is the shapes of dxy, dyz, dzx orbitals are similar to each other, and dx square minus y square and dz square are similar to each other. So this part is not true because dx square minus y square and dz square are different in shape. Okay. So let's see first dx square minus y square. Suppose this is the y-axis, this is the x-axis. Okay. So here will be the dx square minus y square and the orbital will have this type of shape. Got it? So this is the shape for dx square minus y square. Now for dz square, again we'll draw the x-axis and y-axis first. This is x-axis, this is y-axis. So the shape will be something like this. Okay. So as you can see, the shapes are different for dx square minus y square and dz square. So the last statement is incorrect statement. That means out of the given options, option D is incorrect. Now question number 69 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is the Geldar's method for the estimation of nitrogen can be used to estimate the amount of nitrogen in which one of the following compounds. So it is already mentioned that Geldar's method is used for the estimation of nitrogen in a compound, right? Now what are the steps involved in Geldar's method? There are three main steps. In the first step, an organic compound containing nitrogen is heated with concentrated sulfuric acid to give ammonium sulfate. Okay, so this is the first step. Now, in the second step, this ammonium sulfate is further heated in excess sodium hydroxide and it gives sodium sulfate plus ammonia gas plus water. Okay. So two molecules of water are there. Now, in the last step, this liberated ammonia gas, 2NH3, is absorbed in standard solution containing sulfuric acid. So here, how do we estimate the amount of nitrogen? We determine the amount of ammonia liberated by estimating the amount of sulfuric acid consumed in the reaction. Okay, the more ammonia released, the more sulfuric acid will be consumed, right? So this was the basic about the Geldar's method. Now what's important to know here is that there are some exceptions to Geldar's method. Okay, so for some compounds Geldar's method will not be applicable. Okay, so it is not applicable for the compounds containing nitro group, for the compounds containing an azo group, or for the compounds in which nitrogen is present in the ring. Okay, so other than these three exceptions, this method will be applicable. Okay, now have a look at the options. In the first option you can see there is a nitro group, right? So Geldar's method will be applicable or not? No. Okay. Now in the second one, nitrogen is present in the ring. So again, it is mentioned here that whenever nitrogen is present in the ring, Geldar's method will not be applicable. So again, it will not be applicable for option B. In option D also you can see there is an azo group, nitrogen-nitrogen double bond. So it will not be applicable for this as well. So the only possible compound is this one. Okay, that means option C will be the correct answer. Alright, now question number 70 is from the P block elements and here we have to choose the correct statement. The first statement is diamond and graphite have two-dimensional network. So this is an incorrect statement because both diamond and graphite have three-dimensional network. Okay. Now the second one is diamond is covalent and graphite is ionic. Again, this is an incorrect statement because both diamond and graphite are covalent in nature. Now let's move to the next one, that is Diamond is sp3 hybridized and graphite is sp2 hybridized. Yes, this is a correct statement. Let's have a look at the structure in each case. First, we'll see diamond. In case of diamond, each carbon atom forms sigma bonds with 4 neighboring carbon atoms. Okay, and the shape is tetrahedral. Okay, so this is sp3 hybridized carbon of diamond. Now, what happens in case of graphite? Here, the shape is trigonal planar because each carbon is attached to 3 carbon by sigma bond and the fourth electron forms a pi bond. Okay, so this is trigonal planar in shape and this central carbon is sp2 hybridized. Okay, so option C is the correct one. And the last one says both diamond and graphite are used as dry lubricants. So this is wrong for diamond because only graphite can be used as dry lubricants where oil cannot be used. Okay, so only correct option will be option C. Question number 71 is from the S block elements and the question is identify the incorrect statement from the following. First statement is alkali metals react with water to form their hydroxides. Okay, so this is a correct statement. We know that alkali metals belong to group 1 of the periodic table and they form hydroxides by reacting with water. And remember that the alkali metal hydroxides are very strong bases. Okay. Now let's have a look at the chemical reaction here. This is the alkali metal. It reacts with water molecule to give metal ion plus OH minus ion plus hydrogen. Okay. What is M here? It is the alkali metal. Now, the next statement is the oxidation number of K, that means potassium, in KO2 is plus 4. So, KO2 is a superoxide. Here we just need to remember one thing, that the oxidation number of alkali metals in all their compounds is always same and that is equal to plus 1. Okay. So, no matter what the compound is, the oxidation number of alkali metals will remain plus 1. So plus 4 is an incorrect option. That means statement B is incorrect. Okay. So we have already got the incorrect statement here. Let's discuss other options as well. In statement C, it is mentioned that ionization enthalpy of alkali metals decreases from top to bottom in the group. So what happens from top to bottom? The size of the atom goes on increasing, right? So what happens? The effect of increasing size outweighs the effect of nuclear charge. Okay, increasing size outweighs the nuclear charge. Okay, so what happens? The nuclear pull will be reduced, so the outermost electrons will be well shielded or screened from the effect of nuclear charge. Okay, so it will be easy to remove the electrons. That means the ionization enthalpy will go on decreasing as we move down the group. Got it? So statement C is also a correct statement. Now the last statement is lithium is the strongest reducing agent among the alkali metals. Again, this is a correct statement. Let's see how. We know that lithium will make the small ion, right? So due to the small size of ion, what will happen? It will have highest hydration enthalpy. Okay, enthalpy. In fact, this lithium makes the smallest ion. Okay, smallest. That means it will have the highest hydration enthalpy and due to this it will have high negative E0 value, right? And higher the negative E0 value, more is the reducing power. Okay, that means it will be the strongest reducing agent. Got it? So this was the explanation for this question. Question number 72 is from the chapter States of Matter, and the question is which one is not correct mathematical equation for Dalton's law of partial pressure? P is the total pressure of the gaseous mixture. Okay, so we know that according to the Dalton's law of partial pressure, the total pressure by the mixture of non-reactive gases is equal to the sum of partial pressures of individual gases. Okay, so if P1, P2 and P3 are the individual partial pressures of the gases, then obviously P will be the total pressure. Okay, that means the first equation will be a correct equation. Okay, now we also know that P into V is equal to nRT. Okay, so here P is the pressure, V is the volume, N is the number of moles, R is the gas constant and T is the temperature. Okay, so what will be the value of P? Pressure will be equal to nRT by V. So if we are talking about the partial pressures, that means P1 will be equal to N1 into RT by V. Similarly, P2 will be equal to N2 into RT by V. Okay, so this way option B will also be a correct one. Okay, because N1 RT by V will denote P1. Similarly, P2 will be denoted by N2 RT by V, right? So this is also a correct equation. Now we come to the third one. It says the partial pressure of gas I is equal to the mole fraction of that gas into the total pressure. Okay, so this is a correct equation. Okay, you have to remember that the partial pressure of a gas is equal to the mole fraction of that gas into the total pressure of the gaseous mixture. Okay, and in statement D, sorry, the equation D, it is saying that the partial pressure of the gas is equal to the mole fraction into Pi naught, that means pressure of ith gas in pure state. So this is not true. Okay, we have to multiply the mole fraction with the total pressure. So out of option C and D, only option C will be the correct mathematical equation and D will be incorrect. So we have to find out the incorrect one, right? So D will be the correct choice for this question. Question number 73 is from the chapter amines, and here we are given two statements. First statement is the acidic strength of monosubstituted nitrophenol is higher than phenol because of electron withdrawing nitro group. Okay, so we know that the nitro group is electron withdrawing in nature and it withdraws electron both by minus I effect and minus R effect. Okay, I is the inductive effect, R is the resonance effect, and minus sign denotes that the electron is being withdrawn. Okay, so this is a correct statement. Now we come to the second statement. It says that orthonitrophenol, metanitrophenol and paranitrophenol will have same acidic strength as they have one nitro group attached to the phenolic ring. Okay, so let's see the structures of orthonitrophenol, metanitrophenol and paranitrophenol. So first I'm drawing the phenol. One OH group is there in phenol, right? Now, in ortho nitrophenol, the nitro group will be just adjacent to the OH group. Okay. In metanitrophenol, it will be here, and in paranitrophenol, it will be here. Okay. So all of them have just one nitro group. So does that mean that they will have same acidic strength? No, because position of nitro group also affects the acidic strength. Okay, this is ortho, this is meta, and this is paranitrophenol, right? Here remember that there will be minus I effect in all of them. Okay, but if we talk about the minus R effect, then only ortho and para nitrophenol will have minus R effect. That means these two will be having both the effects. Therefore, the acidic strength of these two, that means orthonitrophenol and paranitrophenol, will be more than the metanitrophenol, because there will be no minus R effect in case of metanitrophenol. Got it? So these are more. Now, even if we compare the ortho and para, then para will be most acidic in nature. Got it? That means statement 2 is an incorrect statement. All of them will not have the same acidic strength, right? So which option will be the correct one? Statement 1 is correct, but statement 2 is incorrect. That means option C is the correct statement. Question number 74 is from the chapter electrochemistry, and the question is, at 298 Kelvin, the standard electrode potentials of copper ion to copper, zinc ion to zinc, ferrous ion to ferrous, and silver ion to silver are 0.34 volt, minus 0.76 volt, minus 0.44 volt, and 0.80 volt respectively. So on the basis of standard electrode potential, predict which of the following reaction cannot occur. Okay, so let's arrange the given standard electrode potentials in increasing order. Okay, so the minimum is minus 0.76 volt. This is for zinc, right? So zinc ion to zinc. Then next is minus 0.44 volt. This is for ferrous ion. Okay, ferrous ion to ferrous. More than that is 0.34 volt, and this is for copper ion to copper, and the maximum electrode potential is 0.80 volt, which is for silver ion to silver, right? Now, so as the electrode potential will increase, the reactivity will decrease. That means if we arrange the reactivity of these metals, then it will be maximum for zinc, then ferrous, then copper, and minimum for silver. Got it? Now, here we should know that always a more reactive metal displaces a less reactive metal. Okay, so let's have a look at the options here. In option A, we can see that from copper sulfate, we have got zinc sulfate. That means zinc has replaced the copper. So zinc should be more reactive than copper. So here, is it true? Yes, zinc is more reactive than copper. So it can take place. This reaction is possible. Okay. Now, in the second one, we can see that here it is copper sulfate, here it is ferrous sulfate. Okay, that means ferrous or the iron has displaced the copper. Okay, so ferrous should be more reactive than copper. So yes, ferrous is more reactive than copper. So this reaction is also possible. Now the third one is where zinc has replaced ferrous. Okay, so zinc is again more reactive than ferrous, so it is also possible. And in the last one, if we see zinc, this silver has replaced copper from the sulfate solution, isn't it? So is silver more reactive than copper? No, silver is less reactive than copper. So this is not possible. Got it? So option D will be the correct choice for this question. Question number 75 is from the chapter Surface Chemistry. Here we are given two statements. First statement is, in the coagulation of a negative sol, the flocculating power of the three given ions is in the order. So from aluminium ion to sodium ion, the flocculating power is decreasing. Now how can we determine if the statement is true? We'll use a simple rule here that is known as Hardy-Schulze rule. Okay. Hardy-Schulze rule. Now, according to this rule, in case of negative sol, because in the first statement negative sol is mentioned, so what happens in case of negative sol? The flocculating power increases with increase in charge. Okay, that means it is directly proportional to the charge on the cation. Okay, charge of cation. Now, here we can see that sodium ion has 1 plus charge, in barium it is 2 charge, and in aluminium it is 3. Okay, so according to this rule, the flocculating power should also increase from sodium to aluminium because charge is also increasing. So this statement is a correct statement. Okay. Now, for statement 2, it is given that in the coagulation of positive salt, the flocculating power of the three given salts is in the order from NaCl2, that means sodium chloride, to sodium phosphate, it is decreasing. Okay, so here basically we are comparing the flocculating power of anions, that means the negative ions, right? Chloride, then we have sulfate, SO4 2 minus, and then we have phosphate, PO4 3 minus is there. Okay, because Na3 is written here, Na2, so SO4 2 minus. Now in Hardy-Schulze rule, for positive sol, we determine the flocculating power of anions, right? That means negative ions. So here the flocculating power of the anions will also be directly proportional to the charge on them, okay? But it is for anions. Now here, as you can see, that chloride has just one minus charge, okay? For sulfate it is 2 minus, and for phosphate it is 3 minus. So the flocculating power should increase from chloride to phosphate, but here it is given that it is decreasing from chloride to phosphate. So this statement is an incorrect statement, okay? That means only first statement is correct. So option C will be the correct answer. Statement 1 is correct, but statement 2 is incorrect. Question number 76 is from the S block elements, and here we have to match the elements with the roles mentioned in list 2. Okay, so the first one is lithium and it is used in electrochemical cells. Okay, so the correct match for A will be number 2. Now the second one is sodium. So where is sodium used? Sodium is used as coolant in fast breeder reactors, and it is used in liquid state. Okay. So the correct match for B will be number 3. Okay, let me write it down here. Liquid sodium. Okay, not solid sodium. Now, third one is potassium hydroxide, that is KOH. So we know that KOH is quite common as absorbent. Okay, so it is absorbent for carbon dioxide. That means the correct match for C will be number 1. And the last one is cesium. Cesium is used in photoelectric cells. So the correct match for D will be 4. So out of the given options, the correct option will be number D. Okay. Question number 77 is from the chapter amines, and here two statements are given. First statement is primary aliphatic amines react with nitrous acid to give unstable diazonium salts. Okay, so we know that whenever primary amines react with nitrous acid or sodium nitrite in the presence of a strong acid, then diazonium salts are formed. But in case of primary aliphatic amines, the diazonium salts are unstable. Okay, so the first statement is a correct one. Let's have a look at the chemical reaction. So this is the primary aliphatic amine. Okay, R represents the aliphatic group, right? Plus nitrous acid, it will give us the diazonium salt, that means the alkyl group. Then N2 plus Cl minus, right? Now this diazonium salt will soon get hydrolyzed to give alcohol plus nitrogen plus HCl. Okay, so this is the final product, and diazonium salt stays for a very short period of time. Okay, now we come to the second statement. It says primary aromatic amines react with nitrous acid to form diazonium salts which are stable even above 300 Kelvin. Okay, so the formation of diazonium salt is same here. We use the same method, that means reaction with nitrous acid or sodium nitrite in the presence of a strong acid. Again diazonium salt is formed, and this time diazonium salt is stable. But the temperature mentioned here is not the correct temperature, because for the diazonium salt to be stable, we need a temperature of 273 to 278 Kelvin. Okay, not 300 Kelvin. So this is an incorrect statement. Okay, let's have a look at the chemical reaction. Suppose this is benzene, then amino group is attached to it. That means this is primary aromatic amine. Now it will react with the nitrous acid. This time the temperature should be 273 to 278 Kelvin, and in this temperature range it will give us the diazonium salt. Okay, C6H5N2 plus Cl minus. So this is a stable diazonium salt. Diazonium salt. So here we have to keep in mind the temperature as well. So out of the given options, which will be the correct one? Option C. Statement 1 is correct, but statement 2 is incorrect. Question number 78 is from the chapter polymers, and the question is which statement regarding polymers is not correct. Okay, so the first statement is elastomers have polymer chains held together by weak intermolecular forces. So this is a correct statement. Why? See, as the name suggests, elastomers should have elastic properties, right? So these weak intermolecular forces or weak binding forces permit the polymer to get stretched easily. Okay, so they help in stretching of the polymer, right? Now what is the example of elastomers? The example is natural rubber. So we know that natural rubber can be stretched easily, so this is the example of elastomers, right? Now we move to the second statement. It says fibers possess high tensile strength. Again, this is a correct statement. And what is the reason behind high tensile strength of fibers? The reason is strong intermolecular forces. So what is the example of strong intermolecular forces? Hydrogen bond. Okay. So strong intermolecular forces lead to the high tensile strength. Okay. Hydrogen bond is one of the example of such forces, and the example of fibers is nylon 6,6. Okay. Now we move to the third statement. It says thermoplastic polymers are capable of repeatedly softening and hardening on heating and cooling respectively. That means it undergoes softening on heating and hardening on cooling, right? So this is also a correct statement, and the example of thermoplastic polymers is the very commonly used polymer, that is polythene. Okay. Now, the last statement is thermosetting polymers are reusable. Now, this is an incorrect statement. Why? Thermosetting polymers are cross-linked polymers or heavily chain polymers. Okay, so when these polymers are heated, they undergo extensive cross-linking in molds, and then they again become infusible. Okay, therefore these cannot be reused. And the example of thermosetting polymers is Novolac. So when we heat Novolac with formaldehyde, then it leads to the formation of infusible material known as bakelite. Okay, so this bakelite cannot be remolded or reused. Got it? So the only incorrect statement here is statement D. Question number 79 is from the chapter solutions, and the question is in 1 molar solution that contains 0.5 mole of a solute, there is, so in the options we are given the amount of solvent, right? Now 1 molar solution means what? The molality of the solution is 1, okay, and molality is denoted by small m, and that is equal to number of moles of the solute divided by mass of solvent in kg. Okay, solvent in kg. Now here molality is already given, that is equal to 1. Number of moles is also given 0.5, and mass is not given. Okay, so we will try to find out the mass. So simply mass will be equal to what? 0.5 divided by 1, that means 0.5 kg only. Okay, and here the mass is given in milliliter or gram. So if we convert 0.5 kg into gram, it will be equal to 0.5 into 1000 gram, that means 500 grams, right? So out of the given options, option B will be the correct answer. Question number 80 is from the chapter alcohols, phenols and ethers, and here we are given a reaction and we have to find the Y in this reaction. Okay, so as we can see that Y is some intermediate of this reaction, right? Now let's write the reaction again. First we have an RMgX, so we know that R represents an alkyl group and X represents a halogen. Okay, so this is alkyl magnesium halide, which is Grignard reagent. Okay, so Grignard reagent here is reacting with carbon dioxide, which is a linear molecule, isn't it? Now some compound will be formed, that will be Y. Okay, so let's see what compound will be formed. First we know that magnesium is a metal, so it is more electropositive than carbon, so it will acquire a partial positive charge, whereas alkyl group or carbon of the alkyl group will acquire a partial negative charge, right? Now if we see this carbon dioxide, then here oxygen is more electronegative. So oxygen will acquire a partial negative charge, whereas carbon will have partial positive charge, right? Now this negative alkyl group will attack the positive part of carbon dioxide, that means carbon. Okay, so this alkyl group will react with carbon and the positive magnesium halide will react with negative oxygen. Okay, so what will be formed? C double bond O. This double bond O will remain same, but here one alkyl group will be added to carbon. Okay, because here alkyl is negative and carbon is positive, and this to this negative oxygen the positive magnesium halide will be added. Okay, so oxygen will have negative charge, whereas magnesium will have positive charge, isn't it? Now this is the intermediate Y, and when hydrolyzed, what will be formed? This magnesium halide will be removed from here and one hydrogen will take place. Okay, take the its place, magnesium halide's place. So it will be C double bond O, and here we will have OH. So what is formed? Carboxylic acid is formed, and here we will get MgOH X. Okay, so here we have to determine Y, that means the intermediate. So this is this one, that means option A is the correct one. Okay. Question number 81 is from the D and F block elements, but the concept of electrochemistry has to be used here. Okay, so two half cell reactions are given. First one is this, where manganate ion is getting reduced to manganese ion, right? So reduction is taking place here, and we know that reduction takes place at the cathode, right? And what else is given? The electrode potential for manganese to manganate is given, right? But we need the electrode potential for manganate to manganese, okay? Because manganate is getting reduced to manganese, isn't it? So that will be equal to just the reverse of this, that means plus 1.510 volt, right? Now, so this is taking place at the cathode, that means the next half reaction will take place at the anode, okay? And here the electrode potential is given as plus 1.223 volt. Now we have to find out the E naught cell, and that is equal to E naught cathode minus E naught at the anode, right? So here E naught cathode is 1.510 volt. So 1.510 volt minus anode is 1.223, right? So 1.223 volt. Now if we subtract this, we'll get 0.287 volt, right? Now is this reaction possible? Yes, because E naught cell is positive. So we can say that E naught cell is positive or greater than 0. Therefore, the reaction is spontaneous. That means the reaction is possible. Okay. So the answer will be yes, it is possible, and E naught cell is plus 0.287 volt. Right. Question number 82 is from some basic concepts of chemistry and more specifically mole concept. Okay. The question is, what mass of 95% pure calcium carbonate will be required to neutralize 50 ml of 0.5 molar HCl solution according to the following reaction. So this is the given reaction and we have to calculate up to second place of decimal point. Okay. Now let's talk about calcium carbonate first. Mass is what? 95% pure, that means 95 by 100 m. Okay, and molar mass of calcium carbonate will be 40 plus 12 plus 16 into 3, because oxygen has atomic mass 16 and 3 oxygen are there, so 16 into 3. So if we add all of them, we'll get 100. Okay. Now, what will be the number of moles of calcium carbonate? It will be equal to mass by molar mass. That means 95 by 100 m divided by 100, right? So this is the number of moles of calcium carbonate. Now, similarly, we'll find the number of moles of HCl. So if we talk about HCl, what is given here? Volume is 50 ml. That means 50 divided by 1000 liter. Okay, because we have to find in liter. Now molarity is given as 0.5. So what will be the number of moles? It will be equal to molarity into volume. Why? Because molarity is equal to number of moles divided by volume. Okay. So number of moles will be equal to molarity into volume. So it will be equal to 0.5 into 50 divided by 1000. Right. Now here if we look at this reaction, you will see that for 1 mole of calcium carbonate, 2 moles of HCl are required, right? 2 moles of HCl. That means if the number of moles of calcium carbonate is 1, then HCl will be 2. That means it will be doubled. So this number of moles of calcium carbonate will be half of the number of moles of HCl, or we can say that number of moles of HCl will be double the number of moles of calcium carbonate according to the given reaction. Okay. So number of moles of HCl is what? Here 0.5 into 50 divided by 1000, and that is equal to twice the number of moles of calcium carbonate. That means this one. Okay. This one 95 by 100 m into 1 by 100. Okay. Now if we solve this, we'll get the value of mass, that is equal to 1.315 gram. Now we have to find up to second place of decimal point. So now if we round it off, so we'll get 1.32 grams. Okay. So out of the given options, option B will be the correct answer. Question number 83 is from the chapter Equilibrium, and the question is the pH of the solution containing 50 ml each of 0.10 molar sodium acetate and 0.01 molar acetic acid is. Okay, so we have to find the pH of this solution. As we can see, the acetic acid is a weak acid. So this is a mixture of weak acid and salt of its conjugate base. That means this is an acidic buffer, right? And what is given here, pKa of acetic acid is given as 4.57. Now we know that in case of acidic buffer, the pH can be found out as pKa of the acid plus log concentration of salt by concentration of the acid, right? So this is an important formula. pKa of the acid is given as 4.57 plus log concentration of salt is what? 0.10 molar. Okay, so we can write 0.1 by concentration of acid, that means 0.01 molar. Now here we'll get 4.57 plus log, this side if we remove the decimal we'll get 10. Okay, so log 10. So what will be log 10? It is equal to 1. That means 4.57 plus 1. So we'll get 5.57, right? So this will be the answer. That means option A will be the correct answer. Question number 84 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and here we have to match the products with one of the reactants. Okay, so the first one is cyanohydrin. As the name suggests, it should have a cyano group, right? So this side you can see there is hydrogen cyanide, so cyano group is there. When carbonyl compound react with hydrogen cyanide, it leads to the formation of cyanohydrin. So the correct match for A will be number 4. Okay, now come to the second one, that is acetal. Okay, so when carbonyl compound react with an alcohol, it leads to the formation of acetal. So the correct match for B will be number 3. Now last two options, Schiff's base and oxime, both consist of nitrogen. Here also you can see two options are left and both consist of nitrogen. Now the difference is that in Schiff's base, the nitrogen consists of 3 alkyl groups and no other group is there. So no OH is required. Okay, whereas in case of oxime, OH is also required. So the correct match for C will be number 2, whereas for D it will be number 1. Got it? So C will be number 2 and D number 1. So out of the given option, option D will be the correct answer, right? Question number 85 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which amongst the following is an incorrect statement? Okay, so three are correct, one is incorrect. The first one is the bond orders of O2 plus, O2, O2 minus and O2 2 minus are 2.5, 2, 1.5 and 1 respectively. That means in the decreasing order, right? So this is a correct statement. Okay, now we come to the second one. C2 molecule has 4 electrons in its 2 degenerate pi molecular orbitals. Again, this is a correct statement. See, 2 hydrogens will be there to each carbon. So 2 electrons this side and 2 electrons this side for each carbon. So 2 electrons from this carbon and 2 electrons from this carbon. So total 4 electrons. Okay. So this is also a correct statement. Now the third statement is H2 plus ion has 1 electron. So we know that H2 means 2 electrons. Now 1 plus means 1 electron removed. So 1 removed, how many left? Only 1 electron left. So this is also a correct statement. Okay. Now the last one is O2 plus ion is diamagnetic. Now here we know that oxygen has 8 electrons because its atomic number is 8. So O2, that means the oxygen molecule will have 2 into 8 electrons. That means 16 electrons. Now 1 plus means what? 1 electron removed. So how many electrons left? 15 electrons left. Okay. So out of 15, 14 can be paired. So only one will remain unpaired. Okay. One electron will remain unpaired. So it will be paramagnetic, not diamagnetic. Okay. For diamagnetic, all the electrons should be paired. Okay. So this is not a correct statement. So the incorrect statement is option D. Question number 86 is from the chapter Alcohols, Phenols and Ethers. Here we are given two statements. First statement says, in Lucas test, primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with concentrated HCl and zinc chloride known as Lucas reagent. Okay, so this is a correct statement because this combination concentrated HCl plus zinc chloride is known as Lucas reagent and it is used to distinguish between primary, secondary and tertiary alcohols. Okay. Now we come to the second statement. It says primary alcohols are most reactive and immediately produce turbidity at room temperature on reaction with Lucas reagent. So this is an incorrect statement because not primary alcohols but tertiary alcohols produce turbidity at room temperature immediately. Okay. So let's see, suppose we have a primary alcohol, that means 1 degree alcohol, and it is made to react with the Lucas reagent, that means concentrated HCl plus zinc chloride. Then what will happen? No turbidity will be seen at room temperature. Okay. This is the reason this second statement is incorrect. Okay. Now let's talk about secondary and tertiary alcohols as well. So in case of secondary alcohol, what will happen? It will be made to react with the Lucas reagent. Then turbidity will be seen at room temperature, but after few minutes, about 5 minutes, you can see the turbidity. Okay. Whereas in case of tertiary alcohols, immediately turbidity will be observed. Okay. So turbidity will be seen immediately at room temperature. Okay. Therefore, which option will be the correct one? Option C. Statement 1 is correct, but statement 2 is incorrect. Question number 87 is from the chapter Atoms, and the question is, if radius of second Bohr orbit of helium plus ion is 105.8 picometer, then what is the radius of third Bohr orbit of lithium 2 plus ion? Okay, suppose the radius of helium ion is R1 and radius of lithium ion is R2. Okay, so we know that radius of nth orbit is proportional to n square by z. So n is the number of orbits. So if it is second orbit, then n will be 2. Okay, and z is the atomic number of the element, right? So what will be the value of R2 by R1? R2 is lithium, right? So it will be equal to N2 square by Z2 into Z1 by N1 square, right? So here R2 is for lithium. That means N2 will be the orbit of lithium. So it is third Bohr orbit. So it will be 3 square. That means 9 divided by Z2. So the atomic number of lithium is again 3, right? And atomic number of helium is Z1 is 2, whereas number of orbit is also given 2, so 2 square here. Got it? So it will be equal to what? 9 by 3 into 2 by 4. So again here it will be 2, here it will be 3. So here we'll get 3 by 2. Got it? Now it is also given that the radius of second Bohr orbit of helium plus is 105.8. That means R1 is given. So R2 by R1 will be equal to what? R2 is unknown. R1 is given as 105.8 picometer, and that is equal to 3 by 2. Here we have seen R2 by R1 is equal to 3 by 2. So now we can find out the value of R2. It will be equal to 3 by 2 into 105.8 picometer, right? Now if we solve it, we'll get 158.7 picometer. That means which option will be correct? Option A will be the correct answer. Minutes. Okay, so rate constant for the reaction in per minute is, okay, rate constant, that means we have to find K, and time is given as 5 minutes, right? So we know that for the first order reaction, how do we find rate constant? The rate constant is given as 2.303 by T, where T is time, into log initial concentration of the reactants by final concentration, that means concentration after time t. Okay, so let's put the values here. 2.303 by time is what? 5 minutes, right? Log initial concentration is given as zero point 0.1 molar, so 0.1 by final concentration, that means 0.001 molar, right? Now here we'll get 2.303 by 5 into log 100. Okay, this side if we remove the decimal, we'll get 100. Okay, so log 100 is 2, because log 100 means log 10 to the power 2, so that will be equal to 2. Okay, so here we'll get 2.303 divided by 5 into 2. So on solving this, we'll get 0.9212, and the unit will be per minute. So out of the given options, option B will be the correct answer. Now, question number 89 is from the chapter States of Matter, and the question is, a 10-liter flask contains 64 grams of oxygen at 27 degrees Celsius. We have to assume that oxygen gas is behaving ideally. So the pressure inside the flask in bar is, okay, so the unit of pressure should be bar. The gas constant, that means R, is given as 0.0831 liter bar per Kelvin per mole. So this is simply formula based question. We know that for an ideal gas, what equation we use? We use PV equals to nRT, right? So here P means pressure of the gas, V is the volume of the gas, N is the number of moles of gas, R is the gas constant, and T is the temperature of the gas, right? So here we have to find out the pressure. So P will be equal to nRT divided by V. Okay. So what is N? That means number of moles is equal to given mass by molecular mass of oxygen. So given mass is 64 grams. 64 divided by molecular mass of oxygen will be what? 16 into 2. So 32. So if we divide it, we'll get 2. That means number of moles is 2. So here we'll put the value of N as 2. R, that is gas constant, is already mentioned in the question, 0.831, right? And temperature is 27 degrees Celsius. That means 27 plus 273 Kelvin. So in Kelvin, what will be the temperature? It will be 300. So this temperature we have to put in the formula. So 300 and here volume is 10 liter. Okay. Now if we solve this, we'll get 4.9 bar pressure. Okay. So out of the given options, option D will be the correct answer. Question number 90 is from the chapter Organic Chemistry, some basic principles and techniques. And the question is the correct IUPAC name of the following compound is. Okay, so this is the compound. We can see that this is the longest chain and bromine is added at the first carbon. Okay, so this is C1, then this is C2, then 3, 4, 5 and 6. Okay, that means the longest chain consists of 6 carbons. So we'll write hex as the root word. Now, if we write the functional groups alphabetically, then first bromine comes. That means at first position bromine is there. So 1 bromo will be written. Okay. Then after B comes C. So chlorine will be mentioned next, which is at the fifth position. So 5 chloro. Okay. And then at fourth position we have a methyl group. So we'll write 4 methyl hexane, and since a hydroxyl group is there at third position, so it is an alcohol, so hexane 3 all. Okay, so this will be your correct IUPAC name. That means out of the given options, option A will be the correct answer. Got it? Question number 91 is from the chapter Environmental Chemistry, and the question is the pollution due to oxides of sulfur gets enhanced due to the presence of options are particulate matter, ozone, hydrocarbons and hydrogen peroxide. So choose the most appropriate answer from the options given. Okay, so except for hydrocarbons, all the three options are involved in pollution due to oxides of sulfur. Let's see how. If we talk about the first one, that means particulate matter, then these act as catalyst. Okay, that means they catalyze the reaction of sulfur dioxide to sulfur trioxide, and we know that sulfur trioxide are harmful for the environment as they cause pollution, right? Now if we talk about the second one, that means ozone. So ozone is O3. So what happens when sulfur dioxide reacts with ozone molecule? One of the oxygen from ozone adds up to sulfur dioxide to make sulfur trioxide, and what is left here? O2. That means oxygen molecule, right? So again SO3 is formed. Again it is responsible for the pollution, right? Now we come to the fourth one, hydrogen peroxide, that means H2O2. Okay, so what happens when sulfur dioxide reacts with hydrogen peroxide? This time sulfur trioxide is not formed. What is formed? Sulfuric acid. Okay, again this is harmful to the environment. So which option will be correct? Option B. A, B and D only. Question number 92 is from the chapter Solid State, and the question is copper crystallizes in FCC unit cell with cell edge length of 3.608 into 10 to the power minus 8 centimeter. The density of copper is 8.92 grams per centimeter cube. Then calculate the atomic mass of copper. That means M has to be calculated. Okay. Now we know that density can be calculated as Z into M divided by Na into A cube. Okay, so what is Z here? It is the number of atoms per unit cell. Okay, so in case of FCC, Z is equal to 4. Okay, now M is the atomic mass that has to be calculated here. Na is the Avogadro number, that's always constant, and A is the edge length. Okay, it is also given in the question. And what is D? D is the density. Now, here we have to find out the atomic mass, that means M. So, M will be equal to density into Avogadro number into cube of edge length divided by the Z, that means number of atoms per unit cell. So, here density is given as 8.92. Avogadro number is always constant, and that is equal to 6.023. into 10 to the power 23 into edge length is what? 3.608 into 10 to the power minus 8, and we have to find the cube of edge length, right? Divided by z, that means 4. Okay, so here if we calculate, it will be 8.92 into 6.023 into 10 to the power 23 into the cube of this will be what? 46.97 into 10 to the power minus 24 divided by 4. Okay, now on solving this complete expression, we'll get 63.08. Okay, so that will be equal to 63.1 U or unit. Okay, so option A will be the correct answer here. Question number 93 is from the chapter electrochemistry, and the question is find the EMF of the cell in which the following reaction takes place at 298 Kelvin. Okay, so this is the given reaction. E naught cell is given and the value of 2.303 RT by F is also given. Okay, now if you find the Kc, that means equilibrium constant of the reaction, then it will be equal to the concentration of nickel ion by concentration of silver ion raised to the power 2. Okay, nickel is the product and silver is the reactant, right? Now the concentration of nickel ion is given as 0.001, that means 10 to the power minus 3. Okay, and the concentration of silver ion is also given as 0.001, again 10 to the power minus 3, but since it has a square, so there will be 10 to the power minus 3 into 10 to the power minus 3. So 1 10 to the power minus 3 will be cancelled. What will be left? 1 by 10 to the power minus 3, that will be equal to 10 to the power 3. So we have found the value of Kc. Okay. Now, how can we find the value of EMF of the cell? E cell is given as E naught cell minus 2.303 RT by NF log Kc. Okay, so this is the formula to find the EMF of the cell. Now, what is N here? The number of electrons transferred. So here 2 electrons are getting transferred, so N will be 2. Okay, so E naught cell is given as 10.5 volt minus 2.303 RT by F. This value is also given in the question, 0.059. Okay, so 0.059 divided by N, that means 2. Okay, log Kc also we know right now, so that is 10 to the power 3. Okay, now 10 to the 10.5 minus, if we divide 0.059 by 2, we'll get 0.0295, and log 10 to the power 3 means 3. Okay, so it will be equal to 3, and on solving this we'll get 10.5 minus 0.0885. On subtracting, we'll get 10.4115 volt. Okay, so out of the given options, this is not mentioned in any of the given options, so option E will be the correct answer. None of the options are correct. Okay, now question number 94 is from the chapter alcohols, phenols and ethers, and the question is the product formed from the following reaction sequence is. Okay, so first we have a benzonitrile. So let's draw this first. This is benzene ring and this is benzonitrile. Okay, now in the first reaction, it is made to react with lithium aluminium hydride and then it is hydrolyzed. Okay, so lithium aluminium hydride is a reducing agent. So 4H, that means 4 hydrogen will be added to the cyano group. Okay, so what will we get here? Here the benzene ring will remain as it is, and here we'll get CH2 NH2. So NH2 means it is a primary amine now, right? Now in the next reaction, what happens? This primary aromatic amine is made to react with nitrous acid plus HCl. Okay, so what happens when a primary aromatic amine reacts with nitrous acid plus HCl? It forms a disonium salt, right? So next what will be formed? A disonium salt will be formed. That means CH2 N2 plus Cl minus. Okay, this is a disonium salt. Now, when this disonium salt undergo hydrolysis, it will lead to the formation of an alcohol. Okay, what will happen? This N2 plus Cl minus will be replaced by OH of water. Okay, so we'll get here CH2OH. Okay, so out of the given options, which option will be correct? Option D will be the correct answer. Question number 95 is from the chapter coordination compound, and the question is the order of energy absorbed which is responsible for the color of complexes. So three complexes are mentioned here and we have to find the correct order of energy absorbed. Now we know that stronger the field strength of the ligand, more will be the energy absorbed by the complex. Okay, that means the energy will be directly proportional to the field strength of the ligand, right? Now, how to find which of the given complexes will have maximum field strength? See, in the first one you can see we have two water molecules and two EN, that means ethylene diamine. Okay, so two ethylene diamines are there. In the second one, four water molecules are there and only one ethylene diamine is there. Okay, whereas in the third one, three ethylene diamines are present as ligands. Okay, and we know that ethylene diamine has a stronger field strength than water. Okay, so if we talk about the field strength of ethylene diamine, it is more than that of water. That means the complex having maximum ethylene diamine will have maximum field strength. That means it will absorb maximum energy. Okay, so the maximum energy will be absorbed by the third one, then after that the first one because it has two ethylene diamine, and lastly the second one because it has only one ethylene diamine. Okay, so the correct order will be C, then A, then B. Okay, so out of the given options, option C will be the correct answer. Now question number 96 is from the chapter General Principles and Processes of Isolation of Elements, and here we have to match the ores with their correct composition mentioned in list 2. Okay, so this is simply memory based question. We know that hematite and magnetite both are the ores of iron, but hematite is Fe2O3 and magnetite is Fe3O4. Okay, so the correct match for A is number 3 and the match for B is number 1. Okay, now next is calamine. What is calamine? It is zinc carbonate, and the last one is kaolinite. So this is the ore of aluminium and it is hydrated aluminium silicate. So this is already correctly matched here. That means out of the given options, option B will be the correct answer. Okay. Question number 97 is from the D and F block elements, and the question is in the neutral or faintly alkaline medium, potassium permanganate oxidizes iodide to iodate. So the change in oxidation state of manganese in this reaction is from, so we have to determine the change in oxidation state. Okay, so let's write the chemical reaction for this. It will be potassium permanganate, that means KMnO4, plus iodide, that means I minus. The medium is neutral or faintly alkaline. Okay, faintly alkaline means weak alkaline. Okay, now what will be formed here? MnO2 will be formed and iodate will be formed. Okay, now we have to determine the oxidation state of manganese in potassium permanganate and MnO2, that means manganese dioxide. So in potassium permanganate we know that the oxidation state of potassium will be +1 in all its compound. Okay, manganese, suppose it is X. Okay, and for oxygen it is -2. So 4 oxygen atoms means -2 into 4, and the sum of all these will be equal to 0. So 1 plus x minus 8 will be 0. So x minus 7, 0. That means x will be equal to +7. Okay, so the oxidation state of manganese in the reactant is +7, and here suppose the manganese has oxidation state Y, and oxygen we know it is -2. So 2 oxygen atoms means -2 into 2, and the sum will be 0. So y minus 4 equals to 0. So what will be the value of y? It will be equal to +4. That means the oxidation state of manganese changes from +7 to +4. So option A will be the correct answer. Got it? Alright, now question number 98 is from the chapter hydrocarbons, and the question is compound X on reaction with ozone followed by zinc water gives formaldehyde and 2-methyl propanol as products. So the compound X is, okay, so we have two products here and we have to find out the reactant of this reaction. Okay, so let's write down the structural formula of products. 2-methyl propanol, prop means 3 carbons. So 1, 2, 3 carbons, and it is an aldehyde, so double bond O and an H will also be there. 2-methyl means at second position we will have a methyl group. Okay. Now this is one of the products. Second one is formaldehyde, that means HCHO. So only one carbon is there. So this is the carbon, then double bond O and two hydrogen atoms. Okay. Now we have got two products, and you can see that here there is only one carbon, and in this product we have 3 carbons. Okay. Now this is an ozonolysis reaction which is related to the chemical reaction of alkenes. So the reactant should be an alkene, and the number of carbons in the alkene will be the sum of number of carbons in the products. That means 3 plus 1, that is 4. So the parent alkene will have 4 carbons. Okay, 1, 2, 3 and 4. Now where will be the position of double bond in this alkene? See, here we can see there is one carbon, that means the bond has been broken between first and second carbon. So the first carbon has been separated, right? So this will be the position where the bond has been broken. So the double bond will be somewhere here. Okay. That means at first position we have a double bond. At third position we have a methyl group. Okay. Taking it from here. Now what will be the name of this alkene? It will be 3-methyl but 1-ene. Okay. So option A will be the correct answer. Question number 99 is from the chapter equilibrium. Here a reaction is given. We can see that ozone is being formed from the oxygen, and it is given that for the above reaction at 298 Kelvin, Kc is found to be 3 into 10 to the power minus 59. Now if the concentration of oxygen at equilibrium is 0.040 molar, then concentration of ozone in molar is, okay, so we know that Kc is the equilibrium constant of a reaction, and it is given as concentration of the product by concentration of the reactant, and both will be raised to some power. So ozone will be raised to power 2 because 2 moles of ozone is mentioned here. Similarly, oxygen will be raised to power 3. Okay. Now, here we are given Kc and concentration of oxygen. We have to determine the concentration of ozone. So, concentration of ozone raised to the power 2 will be equal to Kc into concentration of oxygen raised to the power 3. Okay. So, Kc is mentioned as 3 into 10 to the power minus 59 into concentration of oxygen is 0.040. Okay, so 0.04 and the power is 3. Okay, so if we solve it, here we'll get 1.9 into 10 to the power minus 63, that will be equal to 19 into 10 to the power minus 64. We can write it like this. Okay, now this is the square of ozone. So what will be the concentration of ozone? The square root of this, that will come out to be 4.38 into 10 to the power minus 32. Okay, so out of the given options, option A will be the correct answer. And now the last question is from the chapter aldehydes, ketones and carboxylic acids. And the question is, which one of the following is not formed when acetone reacts with 2-pentanone in the presence of dilute sodium hydroxide followed by heating? Okay. So here the reactants are acetone and 2-pentanone. Both contain an alpha hydrogen. So they will undergo aldol condensation reaction. Okay. And multiple products will be formed. So let's see what are the products. The first possible product is CH3, then carbonyl group, then CH, C methyl group, and then 3 carbons, CH2, CH2, CH3. Okay, so this is one of the products. Then other possible product can be CH3, then next carbon containing a methyl group, then CH double bond, okay, then carbonyl group, then 3 carbons, that means CH2, CH2, CH3, okay. Next possibility is that we will have a CH3 group here, then carbon, then here we will have a methyl group, then double bond carbon, and then this carbon containing an ethyl group, then a carbonyl group, and then CH3 again. Next possibility is CH3, then carbonyl group, then CH double bond C having methyl group, and then CH3. Okay. Then the fifth possibility is CH3, then carbon having a propyl group, that means C3H7, then double bond CH, then carbonyl group, then again 3 carbons, so CH2, CH2, CH3. And one more possibility is there, let's write it down here. Sixth possibility is CH3, C, then here propyl group, that means C3H7, double bond carbon having a ethyl group, okay, so C2H5, then a carbonyl group, and then CH3. Okay, so these are the possibilities. So out of the given options, option B is not formed in any of the possibilities. Okay, so option B will be the correct choice here. Okay, so this was our series of questions. I hope this series has helped you. Keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. And don't forget to subscribe our YouTube channel. Thank you.